To get the full course, visit www.zdub.com.
Hello everyone, welcome to this course on robotics. This video is brought to you by ZDub Technologies and I am Anmol, your course instructor. In this session, I'll introduce you to robotics. I'll also give you an introduction to our full course. So let's get started. The discussion for this session will be on what is robotics, applications of robots, what will you learn in our course, the projects involved, and what after that. To begin with, let me first tell you what is robotics. Robotics is the intersection of science, engineering, and technology that produces machines called robots. They substitute or even replicate human actions. Robots are electromechanical objects, which means they have a mechanical body and some electrical components and are developed to perform some tasks which are given to them by a set of instructions. This we typically call a code. The robots primarily try to solve a problem, and that is how their invention took place. Traditionally, robots were used as complex problem solvers, but now they are also used to entertain humans. There are various fields in which robots have been deployed. They are even successful. Some of the applications are surveillance, where they are used to guard some area or just used to keep an eye. Cobots are those robots which work alongside humans and directly assist them. Robots used in industries to lift something and pass or to transform something in manufacturing units or helping the medical staff in hospitals are some of the examples. Even they are used in homes as some worker on whom we can easily rely. Landmine detection is another field where robots have proved their worth. It has always been a complex task to detect the landmine. Many times the soldiers would even lose their life. Delivery services are also using drones nowadays. For last mile delivery, drones are used to complete the task. These were some of the tasks which are performed by robots, but nowadays they have been used to entertain or accompany human beings. Sony's Aibo dog is such an example. It is an exact copy of a real dog and has many of the similar emotions which gives a real living being's feel when you see it. So with this, ZDub brings a full course on robotics in which I will tell you about Arduino platform, how to use it, and in fact we will learn how to code in Arduino. Basically, this code will let you give instructions to your bot or a robot. We will also see some boards like the Arduino Nano and the Uno. These are the brain behind execution of all the commands. We can also think them as the brain of the robot. We will have multiple sessions of Arduino in our course. We will also learn about sensors, how they process data and how can we fetch output from it. Mainly, sensors are based on various interfaces, which we will see later in our course. Some sensors which we will use in our projects will be infrared sensor, ultrasonic sensor, to test the obstacle presence, accelerometer and gyro sensor which tells the orientation of that particular robot, and many more. You will also learn how can we use these sensors in some of our own projects. Next, we will see about power management. Basically, you design a robot, code it and integrate it. But how will it work? That is what power does for a robot. Power management is a very essential aspect in any electronic system. All the components work only if they have enough power. So, deciding appropriate power source and to make sure no short circuit or overload takes place. We need to be cautious. In high level, a complete battery management system is also used to make sure that the battery works in a decent condition. Motors are that component which controls a joint of a bit. So, we will also learn about types of motors and motor drivers. You will also learn using them with Arduino. How can we send any instruction to a robot, or how do robots talk? This is what we will learn in the section. We'll see about various communication ways like Bluetooth, Wi-Fi, setting a local network, and also about XBs, LoRaWAN, NRF modules, etc. Later, we will also make projects which will be based on Bluetooth communication using a Bluetooth module. Circuit designing is also a very important aspect in any system. All the electrical components, the power system, the board cannot be directly used. For that, we need to set up a full circuit, and we also need to make sure no short circuit or other problems occur. Initially, we will use a breadboard and jumper cables to set this. In later stages, we will switch to PCB designing, which is basically an advanced version of circuit design. We will also have a complete session dedicated for PCB designing using EagleCAD. Robotics is not limited just to these aspects. It is a very broad and advanced field where various platforms like ROS, which stands for Robot Operating System, and there are some other platforms too. Python has emerged as a reliable language in robotics for artificial intelligence and deep learning. We will see all this in our later sessions. After having enough theory in this field, we'll meet some DIY projects. Basically, it is not possible to build the advanced robot by a person or people like us. So, what we do is we make small level of these big projects. And that is what DIY is. The software we will use will be open source and the components would be much cheaper. In this way, we can get an approximate knowledge of how the things at bigger scale work. So, looking on the projects, firstly, we will start with playing with LED. LED stands for light emitting diode and are of various types. We will work with single LEDs of monotonous color, also with RGB LED. We will also learn how to use the accelerometer and gyroscope sensor, and will make a very exciting project using that, which is the 3D simulation. We will also learn about various displays which are used to show the data obtained by the sensors. This can be the serial monitor or external displays like LCD, OLED, etc. Later stages will also use ultrasonic sensor for distance calculation. And we will also see how we can minimize the error produced. And at the end, we will make a very much exciting project, that is the Bluetooth based remote control car, which you can control using an Android app. We will see a complete procedure and will make our own Bluetooth car as well. There will be many advanced projects based courses too by Zero. That courses you can take once this whole beginner course is done. So I hope you are excited enough to begin with the course. This is it for now. I'll see you in the next session. Thank you. Hello everyone. Welcome to the second tutorial of this robotics course. In this session, we will discuss what are the types of robots and what is the basic fundamental way of developing a robot. So, let's get started. Since we have discussed before that each robot is made to perform a particular task, by this time it would be clear that these mechanical bots come in all shapes and sizes. We know robots are emerging to carry out tasks that humans simply can't. Generally, there are five types of robots: pre programmed robots, which operate in a controlled environment where they do simple, monotonous tasks. Example of pre-programmed robot would be a mechanical arm on an automotive assembly line. The arm serves only a function, that is, to weld a door, to insert a certain part into the engine, etc. And its job is to perform the task longer, faster, and more efficiently than a human. Coming to next type, which is the humanoid robots. These robots that look like or mimic human behavior. These robots usually perform human-like activities like running, jumping, and carrying objects, and are sometimes designed to look like us, even having human faces and expressions. Two of the most prominent examples of human robots are Hanson Robotics Sofia, which we will see in some later slides, and the Boston Dynamics Atlas. The next type is the autonomous robots. These robots operate independently of human operators. These robots are usually designed to carry out tasks in open environments that do not require human supervision. An example of an autonomous robot would be the Roomba vacuum cleaner, which uses sensors to roam throughout a home freely. Teleoperated robots, which are the mechanical bots controlled by humans. These robots usually work in extreme geographical conditions, weather, circumstances, etc. Examples of teleoperated robots are the human-controlled submarines used to fix underwater pipe leaks, or the drones used to detect landmines on a battlefield. A small subcategory could be augmenting robots. Augmenting robots either enhance current human capabilities or replace the capabilities of humans may have lost. Some examples of augmenting robots are robotic prosthetic limbs or exoskeletons used to lift hefty weights. Now, we will look on some really exciting advanced robots. The first one is Sofia, a social humanoid robot which was invented in 2016 by Hanson Robotics. She can see things, identify individuals, and also can have conversations. She can even walk and has more than 60 facial expressions. In these three images shown in the slide, the middle image shows the internal circuitry of the brain of the Sophia, and the other two images show the actual size of the robot. Next is MIT Cheetah, which is the first four-legged robot to do a flip-flop. Let's look at some of its unique features. This is a 9 kg quadruped cheetah, which can run in 2.45 meter per second speed. As you can see, the motion of the cheetah is completely autonomous. All those motions covered by the bot are completely independent. Various motions like translation, rotation, honking, all are done by these cheetah. And with this, you can also see the stability of these robots. Even when the man is kicking it, then too it can reapproach its previous orientation. And this is how the testing phase of the robot was done. Next example is the self-driving cars. The self-driving cars are also in so much craze. This is Tesla's car and has some amazing features. Don't think it to be an animated video, but it is the actual video in the actual self-driving cars application of Tesla. The user first set the destination location, and then all the algorithm, all the processes running behind are such that the number of errors are minimized almost to 0%. Moving next, as talked before, let me show you the Aibo dog, which is an example of human companionship. It has some really amazing gestures and can follow what its master says. So this is Sony's Aibo. Trying to imitate the features of a real dog, this Aibo had some really cool features. Some special features of it include seeing the human, seeing its master, and then behaving as per a real dog. All the actuators are so precisely set that the motions and everything is totally same. The dog also responds to the real music when it hears from someone playing that. And an advanced feature is that when the dog has less battery power, so it automatically goes to the battery source and that charges itself. Now we have seen some amazing examples, so let us see what is the fundamental approach behind making robots. Robots all consist of some sort of mechanical construction. The mechanical aspects of a robot helps it complete tasks in the environment for which it's designed. Robots need electrical components that control and power the machinery. Essentially, an electric current, a battery for example, is needed to power a large majority of robots. Robots contain at least some level of computer programming. Without a set of code telling it what to do, a robot would just be another piece of simple machinery. Inserting a program into a robot gives it the ability to know when and how to carry out a particular task. By now, we have acquired enough knowledge about various robotics aspects and have seen examples too. From next session, we'll start learning various fundamentals. So, this is it for now. Thank you and see you in the next session. Hello everyone. Welcome to the third session of this robotics course. In this session, we will learn about Arduino, its uses, how it is used in robotics and embedded system. Later, we will also see some other options which are there in the market other than the Arduino. So, let's get started. Arduino is an open source electronics platform based on easy to use hardware and software. Arduino consists of both a physical programmable circuit board, often referred to as a microcontroller, and a piece of software. Arduino can interact with buttons, LEDs, motors, speakers, GPS units, cameras, the internet, and even your smartphone or your TV. Arduino boards are able to read inputs, light on a sensor, or you are pressing on a button or a Twitter message and turn it into an output that can be activating a motor, turning on an LED, publishing something online, etc. You can tell your Arduino board what to do by sending a set of instructions to the microcontroller on the board. And for doing that, you use the Arduino programming language. The programming language is based on C and C++ mainly, and the Arduino software, that is the Arduino IDE. We'll study about this in detail, that how to use that Arduino IDE, its downloading and other things. Let me just tell you what open source community is. Basically, open source consists of contributors from all over the world, from minor projects like ours to major developments like a major product developed by a specific company, who share all the assets in terms of information, code, the phases of development, etc. So, Arduino is based on open source electronics projects, that is, all the design specifications, schematics of these boards, software are available openly to all the users. Moving ahead, let's see what this brain comprises of. Basically, this brain is what we call a microcontroller. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, input-output peripherals on a single chip. Seen on a large scale, they are embedded inside devices to control the actions and features of a product. Hence, they can also be referred to as embedded controllers. They run one specific program and are dedicated to a single task. So, we write a set of instructions in a particular programming language, pass it to the controller or the microcontroller, and then it is processed by it. If we do this without any error, what we see is the desired output. Now, let us explore some of the boards of the Arduino family. Starting from the left in this slide, the first board is Arduino Lilypad. Then, in the downward direction, there is the famous Arduino Nano board, which we will be using in our sessions. Then is the Arduino Mega, which is the most powerful Arduino board among these. The smallest one available here is the Arduino Pro Mini, and the last board is the Arduino Uno, which we will also see in our sessions. As per our system, we choose which board will be apt for us. In the course, we will majorly be using Arduino Nano and Uno, so let us look into it. Now, coming to the board specification, we will first see all the pins available and then the other parts. The pins starting with D and then a digit are the digital pins and are used to control digital interface sensors. Digital implies either voltage low or high, so there is nothing more in between. And for Arduino Nano, voltage high means approximate 5 volt voltage and low means 0 volt. The GND pin is the ground pin of the board, and here we have two ground pins present in the either sides. RST is the reset pin for the board. The RX-TX pins are the receiver and transmission pins used in controlling devices like Bluetooth module, GPS sensor, etc. In the lower side of the picture, the 3v3 is the power pin and gives a 3.3 volt output. The analog pins are those starting with A. These are used to control analog interface sensors like the temperature sensor. The 5 volt pin gives 5 volt as the output. To give external power, we use the V in pin. To this Arduino board, 7 to 12 volt supply can be given externally. The mini USB jack is connected with your PC and thus the code gets uploaded. ATmega 328P is the main microcontroller chip which is the brain of the system. It is present in the center part of the board. The other small components are the SMD version of LEDs, resistors and capacitors. This comes the Arduino Uno board. The board size is greater than the Arduino Nano. The Uno has in total 3 power pins, of which one has a power supply voltage of 3.3 volt and other pin provide 5 volt. All power pins have a maximum current of 50 milliamps or 50 milliampere. You can use the V-in pin to power the whole microcontroller with the same recommended voltage of 7 to 12 volt, also perfect for a battery. Of course, if you have the power pins, you also need some ground pins to close the electric circuit. The Arduino Uno has in total 3 ground pins which are all connected internally. On the left side you can see the power pins and the analog pins available. It has 6 pins based on analog interface. On the right side you see the digital pins, ground pin and the RX-TX pins. We have seen their description above with the Arduino Nano. An extra feature in it is the power jack present in the top left side of this figure. So we can also provide power through this. With so many pins available, you can easily read data from sensors or control different motors and actuators. This is what makes Arduino great for learning robotics. It's kind of all-in-one tool to interface all kind of hardware you need to control. By now, you have seen various Arduino boards, but these are not the only microcontrollers available. There are many more categories of microcontroller like MSP430 family developed by Texas Instruments, STM microelectronics microcontroller, etc. Apart from the microcontrollers, there are also microcomputers or microprocessors available like the Raspberry Pi board, about which we will have a detailed discussion over what is it and how it is used in robotics. This was about how you can send your instructions or your commands to the boards. But talking of some advanced stages, if we want to add an extra layer of intelligence to robots, then there is a fully dedicated field known as artificial intelligence, in which by various models, programming languages like Python, we try to teach and make robots learn. This all is some deeper aspect of robotics. The possibilities of the Arduino are almost limitless. As such, there is no way that one single tutorial can cover everything you might ever need to know. That said, I have done my best to give a basic overview of the fundamental skills and knowledge that you need to get your Arduino up and running. If nothing more, this should function as a springboard into further experimentation and learning. So, by now you have got a basic idea of all this. We have also seen the technical aspects of the board. So, this is all for now and see you in the next session.